You're welcome to my YouTube channel. Thank you for stopping by. Now, today we are continuing in our multi-part series on solving non-calculator exam style question. And this is question number 11. We're told that the line y equals to 3x minus 2 crosses the x-axis at G. When you say a line crosses the y-axis at G, for you to cross an axis, that means the other axis, its coordinate on that other axis is 0. This is what I mean. Let's draw an imaginary pair of axes here. If this line is doing this is the x-axis and this is the y-axis. Since it is crossing the y-axis, the coordinate of x here will be 0. Now let's go back to the equation we are given. This equation is the equation of a line. Remember, the general form for the equation of a straight line reads y equals to mx plus c. The m talks about the gradient and the c talks about the y-intercept. Now the y-intercept is just another way of saying where the line crosses the y-axis. So if you compare your equation to this, it's obvious that the gradient of this line is 3 and its y-intercept is minus 2. So our y value here is going to be minus 2. All right. Question number 12. Here we're looking at a vector question. We have vectors p and vector q. We've been asked to find 2p plus q. So the first thing to do is to have your 2 multiplying your p. P is 4, 6, plus your q, which is minus 2, 7. When you're multiplying a vector by a scalar, you need to multiply both the horizontal component, that is the number at the top, and the vertical component, the number at the bottom, by your scalar. So opening this is going to give me 8, 12. Plus minus 2, 7. All right. So when you're adding vectors, you add horizontal plus horizontal, vertical plus vertical. 8 plus minus 2 is going to give us 6. And 12 plus 7 will give us 19. Now we're asked to find the exact value of the modulus of p. The modulus of p is just trying to tell you what is the magnitude of vector p. The magnitude of a vector is given by the square root of its x component square plus its y component square. Just imagine you're finding the hypotenuse of a right angle triangle. All right, so this is going to give us, what is the x component here of p? Let's go back to our original question. The x component of p is 4, so I have 4 square, plus the y component of p is 6, so I have 6 square. So this gives us the square root of 4 square is 16, plus 6 square is 36. And 16 plus 36 is going to give us, what? 52. But we've been asked to give our answer as a surd in its simplest form. If you look critically at 52, we could split it into the square root of 4 times 13. When this 4 goes out, it's going to be square root of 4 times the square root of 13. The square root of 4 is 2. So our final answer is 2 root 13. That is the simplified form of the surd. And finally, for this particular video, we need to find the coordinates of B. A is the point 4, 1, and AB is 3, minus 3, 1. You know, if you think about this as vectors, actually, if you say A is the point 4, 1, it means that really OA, the vector OA, is what? 4, 1. And vector AB is given by what? Minus 3, 1. And if they are asking you for the coordinates of B, is actually asking you for vector OB, which will just be what? OA minus or OA plus AB. Okay, so what you're looking for is really OB. OB will be given by OA plus AB. All right, so this means 4, 1 plus minus 3, 1. Remember, we add 4, 1 to minus 3, 1. 4 plus minus 3 is going to give us 1. And 1 plus 1 will give us 2. Now, this is vector OB. Remember, they are not asking us for vector OB. I only went this way so you can understand or see why this will be our answer. Since they are not asking for vector AB, they're asking us for the coordinate of B. It's almost the same thing. The top is the X value and the bottom is the Y value. So the coordinates of the coordinates of point B will be 1, 2. I hope you understand that. Thank you for sticking to the very end. We'll move on to question number 13 in the next video. Here we'll be talking about circle theorems. Are you excited? I am. See you in the next one. Thank you. Later.